All right. Good morning. Today is January 17th, 2020. This is Math 1, and we're going to be graphing some functions. I've given you a piece of graph paper. Fold it to make 4 boxes. That. I'm not going to go over how to graph a line. At this point, rise and run, I'm hoping. Absolute value. We have done absolute value before. In this box right here, write down the following. Y equals the absolute value of x. You're writing it in the box right here. You're writing that in this box. Underneath it, we're writing down that it makes a V shape. We're going to throw out a teeny tiny net and catch it. Teeny tiny net. Here's our teeny tiny net, a t-table of x and y. We're going to throw out -1, 0, and 1. Teeny tiny net. What is the absolute value of -1?
1.
Bradley, what's the absolute value of 0?
0.
And Nico, absolute value of 1?
1.
In this box, draw a coordinate system and graph that V. Because you've got it right here. You've got boom, boom, boom. It's the whole start of it right there. Oh.
I dropped perfect straight lines. The bottom of this guy is called the vertex. Can you imagine picking this up by the vertex and moving it around and putting it right there? And if I had that vertex and I said, oh, it's right here, could you draw the V right away? Or would you need another net? You would?
No. You just have
Then
to
you just-
make the...
Right, so I think if I brought it right here, I could go, oh, up 1 over 1, and boom, I have my V.
Yeah.
Right, because I know how this guy goes. I could put him right here, and I could go, oh, up 1 over 1, like that, right?
Yeah.
Just, and I could make this V all over the place. I can move him around. Okay. We're going to go on to our next shape.
We're going to come back to this idea of moving. That's what we're trying to do. But before we move them, we got to get our three shapes in. Our next one is going to be a square root function. This isn't new. We did square roots. We threw out nets and caught these guys before, I think. Did we do square roots?
No.
Just absolute values? Graphing functions?
Yeah, that was a math.
All right. Well, our next one is y equals the square root of x. It's going to make a half u on side. So go down, you're on this box right here. And then we'll graph it on the one next to it. We're going to throw out a teeny tiny net. Teeny tiny net. It's a square root. I can't take a square root of a negative, but I can take a square root of a 0. Chris, what's the square root of 0? 0, nice. What's the next number that you know the square root of? Raising a hand out there. What, Chris?
1.
Nice. What's the next number you know the square root of after that?
4.
Nice, and? Our next square root after 4?
That's-
Yeah,
9. So 1 squared, or square root of 1, square root of 4, square root of 9.
9. 3.
And if you plot those, you get something that looks like this. Now, it's curvy, but you're going to be using some software today, and it's not going to be able to curve, so you're just going to connect the dots, and that'll be good enough. So 0, 0, 1, 1, 4, 2, 9, 3. This guy right here is his starting point. On the absolute value, we call it a vertex. Here, I'm just calling it a start. Can you imagine taking that start and dragging it around and dropping it somewhere, and from there, just following the pattern with the points? I could drop it right here, and then I'd go, what? Up 1 over 1, up 1 over 3, up 1 over 5, and I get the exact same thing without having to throw out a net again, because I know what this thing looks like. I know it looks like this, and it goes over 1, up 1, then it goes 1, 2, 3, up 1, then it goes 1, 2, 3, 4, 5, up 1. It's just this kind of pattern that it's forming. So if I said, oh, you know what, build me one right there. Could you build me one right there? Yeah, I said, you know, I want one right here. Right there. Could you build me one right there? As long as I give you the start point, you could just make the graph. Maybe you just copy it off your paper and go, oh, I'm going to put it right there. Cool. Got one more. It's the cube root function. I feel like we've done these.
Maybe not that
Y equals the cube root of x. Graphing function. Oh, you're
you're right. We did. We did parabolas, a line, parabolas, absolute value. Cool. No problem. Keep going. Cube root function. This guy makes a funny S.
Oh.
I'm gonna throw out a little tiny net. I need to know some numbers that we know the cube root of. Go for it.
8.
I know the cube root of 8. I'm actually gonna start with negative 8. What's the cube root of negative 8? Close. Actually,
Wait.
it's the complete opposite.
It's negative 2.
It's negative 2. Because negative 2 times negative 2 is 4 times negative 2 is negative 8. What is another good cube? Chris? Or, yeah, cube. Do you guys know how to square? Cube root, excuse me.
Cube root of what?
It's about negative 32.
Negative 32. So you got to give me a number that when I multiply it, when I cube it, it gets something.
Like
Pick it.
bigger?
Negative 27.
27, actually that is 3. But I don't need to get that big. But 27 is, he's got one. That's a perfect cube.
Negative 1.
Negative 1 is the next one. Negative 1, negative 1. Because negative 1 times negative 1 times negative 1 is negative 1. So the cube root of negative 1 is negative 1.
But a negative times a negative is a positive.
Times a negative is a negative. Because I'm doing, it's flip-flopping.
Could you do negative 6?
I can't because what multiplied by itself 3 times is negative 6. Our next one is 0. The cube root of 0 is 0. Because 0 times 0 times 0 is 0. What is it? Chris is on it. The cube root of 1 is 1. What's my next one? 8. Cube root of 8 is 2. Next one after that would be 27. Next one would be 64. I'm doing 4 times 4 times 4 is 64. So the cube root of 64 is that.
The next one would be
5 times 5 times, what's the next one?
120.
125. Next one after that is like 216 or something. 6 times 6 times 6.
Yeah, 100. No, 216.
Now, today for homework, you're going to do this online, and it's not going to make it super curvy. So here are my points. I have negative 8, negative 2, negative 1, negative 1, 0. For tonight's homework, we're just going to do segments like that. Would it really be segments like that? No, it would be curvier than that. But this is enough. You know how to plot the points and connect it with segments. This guy in the center is called the center. Can you imagine taking this thing by the center and dragging it over here and dropping it right there
and putting a point and then going up 1 over 1. And then over 8 and up 2. And going, oh, look. And then down 1 and then.
Yes.
Yes, you can. So as long as I know where the center is, oh, the center's right here. Boom, 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 boom. Right? Oh, the center's right here. Oh, boom, 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 boom. As long as I know where the center is, I can just move this thing anywhere. I don't have to keep throwing at a net. I just, oh, there's the center, and I look at my paper and I go, oh, I need to go up and over, and I recreate the shape. Questions so far? So I keep talking about moving it. So now let's talk about how do we move these things somewhere else. This is the part 2.
Are we writing this in our notebook?
I will tell you when to write. Next year I'll break this into 2 days. Okay. We're doing this in 1 day. Next year. Here's the absolute value. There's the square root. There's this guy. I just want to move it somewhere else. Right? Because as soon as I tell you, hey, I want you to move it right here, could you draw in the V? Yeah, not even throwing out a net. If I say, oh, move this right here, could you figure? Yeah? Oh, I'll move it right here. Could I go, you know? Yeah? That's what we're about to do. So here's how the movement part of this works. Here it is. I'm excited. It's exciting. We'll start with the absolute value. Y equals, ready? The absolute value of x. Taryn, pick a number. Plus or minus. Gavin, pick a number. Plus or minus. You just took a V and you moved it. You don't know where you moved it to yet, but you just moved it. I'm going to tell you where you moved it. I can look at this and I go, I know exactly where that is. You want to see it? You just took that V and you moved it down 3. You ready for this one? Left or right? Left. What? But Mr. Barr, it's positive. It seems backwards. It's left. 2. Yes, and if it were a negative, it would go right. So all I have to do, got a piece of graph paper here, go ahead. I just come over here, I go, what? I go over 2 and down 3, I'm right there, and I draw my V really fast. Moved it. It's called a translation. We're moving the shape around, we're translating it. You guys, stop on the nose. You ready for square root? JJ, you ready for square root? JJ is ready for the square root. Here we go. Y equals the square root x. JJ, pick a number. -3 it is. Maddie, pick a number.
5.
Plus or minus, +5 it is. I already know what shape this is. I can draw that shape anywhere you tell me to put it. Where are they raising a hand? Where are they telling me to put it? Nico.
Move it up 5,
Nice. And
and then to the right 3.
remember, this seems backwards. Same thing, this seems backwards. And then I just copy my shape. So, okay, where did you guys want me to put this? Up 5. So I'm gonna do the 3 first because you run before you rise. So I'm gonna go over 3, 1, 2, 3, 1, 2, 3, 4, 5, and then over 1, up 1, over 3, up 1, over 5, up 1.
Ta-da.
It's just following a pattern, isn't it?
So on the edge of that,
We're gonna do it edge elastic.
the segments will be like
Yeah, it'll be 3 segments. Yes. Y equals the cube root of x. Miranda, pick a number. 5. Negative or positive? Then Greenlee, pick a number.
Positive 4.
Hey, here's this guy. I'm about to move him around. I'm gonna pick him up right there by his belly button. Where do you want me to move it, Jordan?
Oh, up 5.
Do my overs first. Left or right?
Oh, right.
How far?
5.
1, 2, 3, 4, 5.
Yes.
And then
Up 4.
1, 2, 3, 4. He's right there. That's his belly button. And based off of that,
Yep.
I just draw it in. So you said this was up 4,
Mm-hmm.
and we said this was right 5. And that seems backwards, right? Seems backwards. But it's not. And if you threw out a net, this is what you would get. If you did your net from -5 to 5, you would catch these things exactly where I'm telling you they're going to be. Gavin, question?
Well, yeah, I was just wondering, so.
Like, why is it backwards?
No.
Okay, oh good.
No,
Because that's
I
a
was
hard
just-
answer.
So you can just ignore like the -5 and the 4, like when you're just casting the net, right?
Well, except the -5 and the 4 really tell me where to throw my net. So if I had this, I'd throw it around what? I'd start at like 2 and go out to 10 or something for my net.
I mean, like when you're solving it,
Like when I'm using a t-table,
yeah.
you could use a net for everything. If you want to go -10 to 10, you're going to catch everything. But this, since I already know what shape it should make, this just tells me, hey, just put it right there and then draw the shape in. Ask me the question again. I'm not understanding.
Okay, so, like, you know how, like, in our other problems, it was y equals, like,
We
just
did-
like x or whatever?
Right, we did like y equals x squared.
Yeah,
Or
so-
absolute values, yes.
So, can you just ignore, like, the other numbers when you're trying to do, like, the t-table? Like, can you just solve it as if it were one of the simpler problems we did earlier?
Y equals x minus 2. Okay, I'm going to t-table this. What do you want to put into the t-table?
-1, 0, 1.
Okay. And then I'm going to plug it into this. I have to use that 2 though when I do this.
Okay, so that's what I was wondering.
So you just want to ignore the 2 and just plug it in like this?
Yeah.
So now, if I use that t-table, -1 minus 2 is -3. Absolute value of -3 is 3. 0 minus 2 is -2. Absolute value of -2 is 2.
1 minus 2 is -1. Absolute value of -1 is 1. I could evaluate all these guys too, the same way. If I throw cube root. Let's throw a 13 into this. 13 minus 5 is 8. Cube root of 8 is 2. 2 plus 4 is 6.
Okay, so when you're solving it, you have to use all the other numbers.
Yes, I think my answer is yes. Like if I'm plugging a number into this, I have to think about all the other numbers.
Okay.
Did I answer the question there?
Yes.
I'm going to show you some different equations. Slide number 11. Micah, tell me how to move this thing. You're going to say left or right, and then up or down.
Left 4
Good.
and down 2.
Left 4, down 2, and I draw my V. I just look at how to draw a V. I make a point, a point, a point. I draw the V in.
Don't you have to know the net before you do that?
So my goal here is to avoid the net. I'm not throwing out a net anymore. I know what a V, this is a V shape. I know what it looks like. It's a V that I just moved around.
How do you know if it goes up or down? But like where, how wide is it?
So it is just, the V is as wide as that. So all we're doing is, those 3 graphs we started with, those are the 3 graphs and we're moving them. We're not stretching them, we're not making them smaller or bigger. They are the shape.
So, for example, that absolute value of V is always going to go up 1 over 1.
On tonight's homework. Later on, we're going to learn that when we start throwing a number in front of this, like a 2, it makes the V skinnier. If I throw a 1/2 in front of it, it makes it fatter.
So like the cubed square root, it's always going to make like that S shape?
It's going
or
to.
you just move it?
And yeah, today you've got these 3 shapes that you put on the graph paper. We are taking those shapes and moving them to different locations. Translate. This one. Oh, hey Jordan, where is the start of this one? Tell me how to move it around.
Move it left 3 times.
Left 3
And down 5.
and down 5. What is that? This one is an S shape. What are you going to do with it?
Right 2 and up 1.
Right 2 and up 1, and then I just take my S shape and draw it. This guy right here. This one, I'm looking at Gavin.
6 to the right, down 2.
6 to the right, down 2. Gordon.
1 to the left and 1 up.
1 to the left and 1 up. This one, JJ.
10 to the right and down 9.
10 to the right and down 9. Ooh, look at this. Where do you want me to start this thing, Chris?
1 to the left.
1 to the right.
Or 1 to the right and down 2.
Boom. Okay. And what shape do you want me to draw? A V. Boom, boom, done. Yes.
So really, for tonight's homework, we don't even have to put out a net.
You don't. As soon as you know that one starting point and you know how to draw that shape, you just put in a couple more points and you're done.
Okay.
Let's do another one. Where do you want me to start this one? Presley.
You started at, you go to the left 2 and then down 1.
Right there? Ooh. What shape does this make? Taryn, what shape does it make? The half U on its side? Well, I know how to make that guy. I go up 1, over 1. Then I go up 1 and over 3. And then I go up 1 and over 1, 2, 3, 4, 5. Boom, 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 boom. Done.
Why just
Because I follow the pattern that I've already did on my notes. Do another one, Miranda. Number 19, where do you want me to start this one?
Left one, down 3.
Left 1, down 3, right there. Tell me how to move my finger. Move my finger. Chris,
To the right, or, no.
I need another point. Give me another point.
Oh. And then to go
Up 1.
to the right, and 1 to the right.
Boom, there's a point right there. Get me to a point. Fisher, give me to another point.
You can do up 1 over 1.
That's the same point.
You can go down 1 over 8.
Oh, down 1 over 8. He's right, down 1 over 8, because 8 is a perfect cube, isn't it? Down 1 over, not down 1 over 8 though, down 2 over 8. 1, 2, 3, 4, 5, 6, 7, 8. There's a point. I need another point though. There's a point somewhere over here. You got it, Nico.
Down 1 over 1.
There it is.
After
You got this? Okay, you tell me where to go.
up 2 over 8.
Up 2 over 8. 1, 2, 3, 4, 5, 6, 7, 8. There it is. Now, normally this would be kind of a curvy thing, but from Edge Elastic, it's just going to be segments that join it together like that. Get into Edge Elastic. Please?
I need to draw.
What's this say? Not. One more. Wait, math and statistics.
Or there's this one, right?
Did you not do last night's homework?
No, I didn't.
Which one? There's 4.
I did. Oh, I think I did the other one.
Statistics, optional homework. Oh, I can remove that. Okay, you didn't do that. That's fine. I'll remove those. Okay, there are 2 things in there that we're going to do. One is the practice, and the other one is the homework. The practice and the homework are identical. The homework will be graded, the practice will not. What you're going to do in class is the one that says practice. Once you and I'll give you feedback on it as you're doing it. Once you're done with that, you're going to do the exact same problems again in the homework file for an actual grade. Because you don't want to do the homework and get them all wrong and get an F on it. So it gives you a chance to practice, and then you can do the homework. Yes?
Wait, so if they're the exact same problems, then you just put an answer?
Yep,
We have, like,
exactly.
We have 2
That's
tabs
a,
open.
I don't know if you can do that.
So basically,
Well, except you got to go through all 7 first,
We can
and
still
then
do second.
then if you want to open up a window and then copy it across, that's fine. The goal is to do. I can just do them faster than I can copy them. So start right now with the practice. When you're done with the practice, have me check it before you submit it, and then do the homework. I know it's a little bit weird. Give it a shot.
I'm confused. Can you